Welcome to today's episode of Tech Talk, where we dive into the fascinating world of machine learning advancements and their implications for our future. I'm your host, and today we're unraveling a topic that's both cutting edge and critical for those in the tech community, using differentiated precision for key-value cache quantization in large language models, specifically on Apple Silicon. Now, let's start with the basics. What does it mean to use differentiated precision? Well, in the context of machine learning, particularly when you're dealing with large models, you have to manage how data is stored and processed. This is especially important when you're running models on hardware with limited resources, like Apple's M1 or M2 chips. Imagine you're working at a high-end restaurant, and you need to serve a multitude of dishes efficiently without overwhelming your kitchen. Differentiated precision is like asking your chefs to focus on the critical elements of each dish, giving them just enough time and resources to create something extraordinary, rather than pouring all your attention into every single ingredient. So, here's where KVSplit comes into play. By using this approach, you can store 8-bit keys alongside 4-bit values. This combination doesn't just sound techy, it's actually a game changer. It allows you to significantly reduce the amount of memory required by a staggering 59%. Can you believe that? And yet you suffer less than 1% degradation in performance. It's like a magic trick, but instead of pulling rabbits out of hats, we're pulling efficiency from our computing resources. Now you might be thinking, why does this even matter? Well, think about how machine learning models are integral to everything from personal assistants on our phones to complex simulations in climate science. The ability to innovate and improve these technologies relies heavily on how well we can optimize these models. But let's pivot a bit. What about the implications for developers? If you're someone who writes code or builds applications, understanding these advancements means you can create more responsive, faster applications that use less power. With Apple Silicon leading the charge in portability and efficiency, this opens up a realm of possibilities for developers to push boundaries without the fear of draining their resources. And here's a thought-provoking question for you to ponder. As we make strides in efficiency through innovations like KVSplit, what ethical considerations come into play as our models become more powerful yet resource efficient? Are we risking over-reliance on technology, or are we on the brink of revolutionizing how we live and work? All right, as we wrap up today's episode, let's summarize some key points. Differentiated precision in key-value cache quantization is transforming how we run large language models. Utilizing techniques like KVSplit not only reduces memory usage dramatically, but does so while preserving performance. As developers and users, this has profound implications for the future of tech and efficiency. Thank you for tuning in to Tech Talk. Feel free to share your thoughts on this topic or ask any questions you might have about machine learning advancements. Until next time, keep exploring the tech innovations that are shaping our world.